we are given an array. Okay, for example, 1, 2, 3, 4 is the array. And we are given, yes, it is a CSES problem as well. It's there in the sorting and searching section, sliding window median. Okay, links are available both on LeetCode and CSES. So guys, for this particular problem, you are given an n and k. And for each subarray of size k, let's say k is equal to 3 here, right? You have to print the median of these subarrays. For example, for this subarray, the median is 2, and for this subarray, the median is 3. Is the problem statement clear with everyone, guys? Yes or no? Yes? Okay. So, guys, there are two solutions to this. Okay, I'll share how it is actually supposed to be done right now. And then I will share a hack which you can try out. I'm not going to share the code of it, but that the other solution, which is hacky, but it works, you can try that out by yourself. So guys, our task is to find the median of each window, right? Okay. First of all, what does median mean? I'm sharing that only, Priyansh. You can look at that, right? Our task is to find the median of each window. Now, what does median mean, right? First of all, let's break down the definition of median. Median for an even array and an odd length array, what is it? For odd length and even length. Okay. For an even length array, let's say the length is L, then it is the L by 2th element. Yes or no, guys? And for an odd length array, it is the L by 2 plus 1th element. Yes or no? Yes, when we sort it, okay? After sorting.
Is this with one based or zero based indexing?
I don't think like this is one based indexing because, for example, if it is 4, then the second element after sorting is the median. And for odd length, when it's 5, so it's 5 by 2 plus 1 is the third element after sorting, right? It's one based indexing. Okay. So, guys, if we take an example, if we look at the array 9, 1, 3, 4, after sorting, it becomes 1, 3, 4, 9. And in this case, our median is 3. And similarly for um, 9, 1, 3, 7, 5, after sorting, it becomes 1, 3, 5, 7, 9. And the median in our case is 5. So is this idea clear for everyone, guys? Yeah, sorry. For even, this is not true. I took a different definition. For the problem statement asks that, so sorry for that. 1 second. 1, 3, 4, 9. What the problem asks that, in this case, what the median is. For even length, the median is the average of the middle two values. Since in even there is no middle element as such, the definition is a bit different. It is the average of L by 2 and L by 2 plus 1th element. So sorry for that. Yes. So in that case, it is 7 by 2, which is 3.5. That is the median. And in odd length, 5 is the median. Is this clear, guys? It's just the definition. In some problems, they ask that it should be L by 2. In some problems, they ask it should be mean. Yeah, I think in the CSES version, they are asking the smaller one. Here they are asking for the mean. Okay. So it depends on the problem. It's problem to problem basis. Okay. So guys, this is what we are asked to do. Now, if we had applied a brute force method, what would happen? Right now, you can look at the solution because these are standard problems. It will help you learn. After this, I have a practice problem for you as well. You can check that out and solve it by yourself. Okay. So guys, if we had to apply brute force, what would we do, right? For every subarray, okay, we would sort it and then we would take the middle elements, whatever. We would come to know what is the mean, right? But this is definitely going to result in a TLE. Yes or no, guys? If we go by every subarray and then we sort it and then we take the middle element, it's definitely going to result in a TLE. Now, what are the constraints? N comma k smaller than equal to 1e5, 2e5. You can consider them to be anything, right? Now, guys, one thing is for sure that we need to maintain the elements in some sort of sorted order. Yes or no? It is unavoidable. Like, we will need to maintain in sorted order. Okay. So, if we want to maintain the elements in sorted order, what choices do we have? Either we can use a multiset, okay, or we can use a set, or we can use a map. Now, set we can't use because it cannot handle duplicates. So let's just discard set. We can definitely use multiset or map to solve this. Exactly. And in this problem, for this particular implementation, we'll be moving ahead with the multi-set implementation. You can do it with map as well. It is up to you. But I'll be showing you the multi-set implementation, which is very clean and very easy to implement. Okay? Yes or no, guys? Tell me. Yes? Okay. So, what do we need to do, guys? Essentially, we have our multi-set, right? What do we need to do? We somehow need to find the middle element in the multiset. In the multiset. Yes or no, guys? Tell me. Yes. Now, this could be a bit hard to handle. Okay. So, can we do one thing? We can have two multisets instead of trying to handle what is the middle element in one multiset. We can have two multisets. Okay. Basically, what I'm trying to do is, if this is our, why would it be hard? Because we would be inserting and deleting elements, right? And you want to make sure where, for example, currently the multiset is something like this. Okay. So our median is 3. But after deleting 3, where does this pointer go? Does it go to the left? Does it go to the right? Does it stay as it is? If I insert another 3, is it inserted towards the right, towards the left? We need to be sure of that. And that becomes too complicated if you're in a contest or even in an interview. If you're not sure about it, it's better to just avoid it. Okay. What is the intuition behind using another multiset? Yes, let me share that. Guys, so in median, we can split this array after sorting into two parts, right? The first one contains the first L by 2 smaller elements, and the second one contains the next L by 2 larger elements. Okay. And the advantage we get, can we do something like this using? No, that does not work, Sagar. Why it does not work? Because a multiset is not a linear data structure. Like in a vector, you can do dot begin plus something and it gives you the next index. In a set or a multiset, it doesn't work like this because a multiset is stored as a tree, right? So you can't, it's not stored in consecutive elements. Yes, Lakshay, I'll be sharing that solution as well. Yes. So if I have this as two multisets as low and high, do you guys agree that the largest element in this multiset and the smallest element in this multiset is going to give me the median? Yes or no, guys? If I'm able to split up the multisets into two, one which contains the smaller L by 2 elements, the second one which contains the larger elements, it will give me the mean. As someone rightly pointed out, this is for even case. How do we handle it for odd case? Okay. For odd case, we have two options. Either we can store it in the smaller multiset or we can store it in the larger multiset. As a choice, let's for now store it in the smaller multiset. Okay. So what is going to happen for odd case? For odd case, we are going to split our window like this. The L by 2 plus 1 small elements are here, and the smaller L by 2, the larger L by 2 elements are here. So do you guys agree that the median is just the larger element of the smaller multiset? Yes or no, guys? After sorting, that is. Someone asks for odd, we need to make one multiset size more than the other. Yes, exactly. Yes. So, guys, our only task is to maintain this. If we are up, if we can maintain this, it will become very, very easy to do so. Now, how can we maintain this? Let's have a look. Because first, no. We don't need to sort the array first, Priyam, because the multiset does that for us, right? If we just keep inserting in a multiset, it will store it in a sorted order. Does it make sense? Okay. So, guys, yes, L is the length of the sliding window, Priyansh. Okay. So, what is our task? Our task now is to efficiently hold or efficiently maintain, right? Our task is to efficiently maintain the two multisets. Yes or no, guys? Tell me. Right? Someone asks, can we use a min and max heap? My question is, how would you delete elements from it? We can do the same thing, but how will you delete elements from a priority queue? There is no dot erase function that C++ has given you, right? So, guys, we want to efficiently maintain these two multisets. What is the first property of these multisets? We saw that either low size is equal to high size or low size is greater than high size, right? Let the two multisets be named low and high. Okay. So does this hold true that low size is greater than equal to high size always? Yes or no? And the difference is 2. Like difference is 1. Either low size is equal to high size or low size is equal to high size plus 1. Okay. Now, what can we do to maintain this? Let's have a look. Let's say we have some random numbers. Let's say we have 2, 1, 3, 4. What will we do? Initially, yes, exactly. I'm telling you that, guys. Okay. Initially, both the multisets are empty. Yes or no, guys? Yes. Okay. Now, what will we do? We are starting with these first element. Okay. We will insert this element into our higher multiset. Okay. Now there are two cases. Either low size is equal to high size before putting it. Okay. Or low size is equal to high size plus 1. Right. So either low size is equal to high size or low size is greater than high size. Do you guys agree with this? Yes? Okay. Now, we inserted this into our higher multiset. Right? Now, what will we do? So we put this, right? Now it becomes, this is empty and this is 2. But it might be that this belongs here. Yes or no, guys? Yes. So we will take the smallest element from this multiset and we will insert it over here. For example, currently this is empty, right? So we will just put this 2 here and this is empty. Okay. Now, do you guys agree that these two multisets are split up such that the higher ones are over here and the smaller ones are over here? Can you go one step back and explain from there? Sure. Let me explain everything again. 1 second, guys. Okay. So consider my array is 2, 1, 3, 4. Okay. Okay. Let me do something different this time. I think it will be much easier for you all to understand, and I have implemented that way as well. Okay. We are starting in empty scenarios. Shouldn't we insert? You can do both ways. Let me start with inserting in the lower one. Let me explain it that way. I think it's going to be much more intuitive. Okay. So we are starting from the first element. Okay. Let's say there are some elements already in these two multisets. This is low and this is high. Okay. Let me first insert this into my lower multiset. Okay. After inserting into my lower multiset, do you guys agree that there could be an element that should belong in the higher multiset but is in the lower multiset right now? For example, this element itself. Now, do you guys agree also that this element would be the highest or the largest element in low? Yes or no, guys? Yes. Now, if this is the case, what will we do? We will first insert this element into our lower multiset, and then we will take the largest element from our lower multiset and we will put it in our higher multiset. Yes or no, guys? Tell me. Yes? Okay. Didn't get why like this. Let me tell you. For example, let's how do you access largest? It is just low dot r begin. R begin gives an iterator towards the largest element. Okay. This will give you an iterator or star lower dot r begin. This will give you the largest element in low. Okay. Dot end. Okay. There is a big difference, guys. R begin gives an iterator towards the largest element. Dot end gives an iterator after the largest element, basically where this multiset ends. This won't give you the largest element. This will give you the largest element. Is this much clear? Yes, exactly. The next iterator to RB. Okay. Now, after doing this, let me share my slide. This is 2134. Okay. After doing our operation, yes, it is nlog k. After doing our operation, our multiset became low is empty and high is 2. Okay. Now, tell me, guys, what was our property? Our property was either low dot size is equal to high dot size or low dot size plus 1 is equal to high dot size. Low dot size is equal to high dot size plus 1. Yes or no, guys? Tell me. This was the property we needed to maintain. Yes. So do you guys agree in this case that property is not being maintained? Yes or no? So in this case, if high dot size becomes larger than low dot size, we will just insert the smallest element back into low. And do you guys agree after that our condition will be maintained? It will become 2 and it will become empty. Yes or no? But at the same time, we someone asks that yes, you can do it in the opposite way as well. But at the same time, we want the last element and first element in low and high respectively to be at least equal or greater. I don't get what you mean. You can feel free to unmute and ask it. Ask me the question.
Yeah, like if we have two sets, we are maintaining low and high. The
Yes.
initial condition was the last element. We maintain sorted array, right? So
Yes.
the first half. So the last element in the first set should be equals or lesser than the first element in the higher set, right?
Yes. That is
But if
being
we
maintained, right?
move like two here, so that high will be empty, right?
Yes, but that is what we decided to maintain right here. In odd median, we were planning to maintain the L by 2 plus 1 elements in the smaller one, right? If the size is 1, I would have only one element in my smaller multiset. Yes or no?
Yes.
So in one case, it would hold true. Yes.
Yeah, one
Length
case.
is yes.
Mhm.
So now, guys, if this is done, we have inserted 2. And do you guys see the larger element here is in the largest element in the lower multiset is indeed the median? Yes or no? Yes. Now let's insert 2. Let's say k is equal to 3 here. Okay. Now let's insert 1 and do the same. Yes, k is fixed. In the problem, k is given to be fixed. Okay. Now let's see what happens when we insert 1. This is 2. This is empty. What do? We first insert 1 into our lower multiset. After inserting it into our lower multiset, it becomes 1, 2, and this becomes empty. As discussed earlier, now we will put the largest element of the smaller multiset into our larger multiset. Do you guys agree it becomes 1 and 2? Yes or no, guys? Yes. Now, do these multisets hold their properties? Tell me, guys. Yes? Okay. If these two multisets hold their properties and the length is even, do you see that the largest element here and the smallest element here, if I take the greater than equal to, it is following? Yes. So it is following the condition. And since the length is even now, I can say that the largest element in the low multiset and the smallest element in the high multiset, their average will give me the median. And here the average is 1.5. Do you get this? So Vikram asks, how do you come up with such things on your own? These things you would need to, like, honestly speaking, you would need to see in order to come up with your own. These are very standard ideas. Like it's same as iterating over subsets, iterating over subarrays. If you haven't learned it, it's very hard to come up on your own. Okay. Now, guys, let's insert 3 and see what happens. Okay. So now the multisets are like this. I will insert 3 over here. It will become 1, 3. And now it will become 2. As discussed earlier, I would put 3 inside 2. So it would become 1 and it would become 2, 3. Okay. Now that this is done, do you see that these sets do not maintain the property that is low size is greater than equal to high size? In this case, we would just take the smallest element from high and put it in low. And my multisets now become 1, 2, 3. This holds the property that we wanted. And you can see that the median is this element. Does it make sense, guys? Okay. Now, the thing is, guys, we got it for this particular array. Please repeat the part when we put 3 in high. Okay. So, guys, what are the steps we are going to do? Whenever we get an element, we insert x in low, where x is our element. After this, what are we doing? We are inserting largest element, okay, largest element of multiset low in high, okay. And after that, if condition does not hold, like in this case, if condition does not hold, then we would insert lowest element of high in low. Are these steps clear, guys? We first insert in low, then we insert the largest element of low in high, and after that, if condition does not hold, we insert the lowest element of high in low. Okay. Now, I have a question for you guys. We have got the median for this subarray. How would you do it for this subarray? It is very simple. we want to delete this element and we want to insert this element. Insertion can take place using these steps. How would you delete? Do we need to do anything extra? Think about it for 5 minutes. Do we need to do anything extra to delete, or we can just find and delete? Yes. Can we do that? Tell me, guys. Think about it.
Sir, after deleting, we have to adjust size, I guess.
Okay. Let's have a look. Anish says, can you repeat? Yes. What do you want? Yes, Lynn.
Yeah, if it is has duplicate numbers, it is present in both of the multisets, then it is difficult, right, to delete in which multiset we have to delete.
Okay. Let's have a look which multiset we need to delete. Was everyone able to understand how we are inserting? For the first k elements, how we inserted? That much is clear.
Yes, sir.
Okay. So guys, we need to come up with a strategy to delete. Okay. Let's analyze this thing. I think we can come up with on ourselves, even if we don't know. Okay. There are now two cases, right? Either the first length is x plus 1 and second length is x, or both length are x. For this is for low and this is for high. Okay. Okay. Now guys, tell me, in this case, there it might be possible that we want to delete some element 2, and 2 is there in both of these elements. In 2 is there in like both of these multisets. Which one should we give priority first? Low, right? If we delete from low, the size would become x and the size of high would also become x. And then do you guys agree we can just take care of it using our insert operation, since this is a valid case? Yes or no? But let's say it was not there in low. It means that after deleting, the size would become x plus 1 and x minus 1. Yes or no? Yes? Okay. Now, if this is the case, like I think it should not matter, but okay. If this is the case, our insertion inserts the element first into the low one. So it becomes x plus 2 and x minus 1. And then it inserts from the lower set to the higher multiset. So the size becomes, oops. So
Can
the
you repeat the
size,
last part again?
sure. Which part? Tell me.
If it's not found in low, we delete from high, right?
Yes. If it's not there in low, we delete from high, right? After deleting from high, the sizes become x plus 1 and x minus 1. Yes or no?
Yes.
Yes. Now we would do our insert operation. After deleting, we insert, right?
Correct.
Okay. After inserting, what is our insertion condition? We first insert in our low multiset. So the size becomes x plus 2 and x minus 1. Yes or no?
Yes.
Now, after that, what is our next step? We insert largest element of low in high. So didn't the sizes become x plus 1 and x again?
Correct. Yeah.
So in this case also it is maintained, and in this case it is also maintained. Abhishek Kumar says, how did it become x plus 1? Because the size was x, right? I removed an element, so the size became x minus 1. Yes or no? We remove from high, and here we remove from low. Okay. So it does not matter as such, but you can see that it got balanced in both cases. Now, similarly, do you guys agree that in this case also it will get balanced on its own? Because let's say you remove it from low. So it becomes x minus 1 and x. Okay. After doing insertion operation, it will become x and x. Then you would put the largest element of your low in high. So it would again become x minus 1 and x. And since now the property does not hold, we would do this particular operation, that is insert the lowest element of high in low, and then both will become size x and x. Does it make sense, guys? Yes. Okay.
Yes, sir.
And now if we are removing from the other side, I hope it is clear why it works. Should I explain it? If it is x and x minus 1, why it will work? Okay. No, we only need to do it once. We don't need a while loop. Exactly. Lakshay put it in the chat. So if this much is clear, guys, you understood how to maintain a median of a subarray. Let's have a look at the code. I think the code is very important. You can see that I have two multisets, low and high. And here I have my answer vector for median, right? So what am I doing? I am inserting the element in low. After that, you can see that I am inserting the largest from low to high, right? And of course, since I'm inserting it, I also have to erase it from low. So I am erasing it from low. If you didn't know how to erase from a multiset, since let me share that as well, guys. Let me add it here. Since in a multiset, there can be duplicate elements. If you just do ms.erase2, okay, what is going to happen? It is going to delete all occurrences of 2 and your multiset is going to become empty. That is why what we do is we do ms.erase and ms.find 2. What this is going to do, it is just going to erase the first occurrence of 2 from the multiset. Okay. I
One
tried
side
it.
question.
Yes.
If it returns, say example, end of multiset, it's not related to this, but what happens in that case?
Yes. If this returns end of multiset, then it would not erase. Yes. It is just like a normal erase function. If it returns dot end, it would not erase that particular iterator.
No runtime exception or something like that.
No runtime. It's just like doing ms.erase 21, right? Would it give you a runtime error?
No,
Exactly. It does the same thing. Okay.
thanks.
Excuse me.
Yes.
So in ms.erase2, we are giving the value 2 to erase. So it is erasing all the occurrences of 2. And in second
Yes.
ms.find2, we are giving just one iterator.
Yes.
Okay. Thank
Okay. So dot erase either accepts an iterator or it accepts the value. So that is why I'm using an iterator to find it, and then I am erasing it. After that, this is our main exception handling, or basically the case that we don't want. If low dot size is smaller than high dot size, then we insert the smallest element from high into low and then we erase it from high. I don't think, like, I tried that as well. That was giving me a runtime error. You can try it out by yourself. It wasn't working for. Okay, I think that is the problem with reverse iterators or something like that. How about having a single multiset and declaring is equal to so Nevedyam, what is the issue with that? Each time you would have to iterate k by 2 times, right? So the time complexity would be big O of n into k if you're using an iterator and then you're doing plus plus n by 2 times. And if n is small, so what is Nevedya saying? Nevedya is saying instead of doing all these things, what you can do is you can have an iterator that is towards ms.begin, and then you could do it plus plus k by 2 times. The issue with this is the time complexity would be big O of n into k and extra for whatever your multi-set. Let's not consider that for now. But the simple observation is for n smaller than equal to 2e5, this would give a time limit exceeded. Yes or no? Okay, great. So this is our exceptional handling, and this is for inserting the median into our vector. If it is odd length, then we insert only low.rbegin. If it is even length, this is for odd length and this is for even length. Okay, this is how we check for odd and even using bitwise operators. If it is even length, then I just do the average of low.rbegin and high.begin. After that, here what am I doing? I am erasing the element from the multiset. Erase from multiset. So if it is in low, I erase it from low. Otherwise, I erase it from high. Is this solution clear for every single one? Sir, are you deleting after updating the answer? Don't you think it will cause problems? No. So I am inserting this for, okay. So people are saying, won't it cause an issue? So guys, what am I essentially doing? Let me share. Let's say my k is 3. Okay. And here I calculated the answer for the first subarray. Yes or no, guys? I calculated the answer for the first subarray, right? Let's say it was something. Now, do you guys agree for this particular subarray, I would need to delete this particular element? Yes or no? So if this element is present in low, then I'm deleting it from low. Okay. Otherwise, if it is present in high, then I delete it from high. Okay. And since currently my I is over here, what is this index? This is I minus k plus 1, right? So what am I essentially doing, guys? If I minus k1 is there in low, basically if it is smaller than the largest element, smaller than equal to the largest element in low, then I delete it from low. Otherwise, I delete it from high. How to update after deleting? It gets updated by itself, right? I have deleted it here, and in the next iteration, I am inserting the element which I wanted to insert. Why I minus k plus 1? Because if I have calculated this right here, okay, now for the next iteration, I would need to delete this particular element. Yes or no, guys? For this is I. For iteration I plus 1, I would need to delete this element. Yes or no? So when I am doing this in this iteration itself, if I would have done it here, so what is the index I want to delete? isn't it I plus 1 minus k, which needs to be deleted for the next iteration? Okay, that is why we got I plus k minus 1. So we are deleting in the previous iteration itself for the next iteration. It is not necessary you do that. You can do it. You can do it using I minus k as well. It would just be above. Okay. What I'm trying to say is, instead of having this here, you could essentially have it somewhere here. Okay. We are erasing elements. Are all elements distinct? No, all elements are not distinct. Okay. So is this clear with everyone, guys? Tell me. Yes, it is a bit complicated, but I hope you guys are able to understand. It's not an easy idea. So guys, if this much is clear, there is a homework problem for you all. Okay. Okay. What is the problem? The problem is that for every subarray of size k, you need to find the minimum cost to make all elements equal. Okay. And what is the cost of making? Yes. How can we make all elements equal? Either you can increase each element by 1 or decrease each element by 1. This is one operation. So the cost is the number of operations it will require to make all elements equal. For example, in 2, 3, 4, the answer is 2 because I can make this into 3, 3, 3. Exactly. Yes, this is there on CSCS. Okay. It is just a variation of this problem. Right? Yes, I will share both ideas where maps is used. Did not get it. Why we need K? We need to solve it for each subarray. Let me share the problem, guys. The problem is that you are given an array, okay, and you are given K. For every window of size K, you need to tell me what is the cost of making all elements equal. It doesn't matter, right? If K is even, if K is odd. I want to know what is the cost. Yes, Ritesh, that is exactly what we need to do. This is a homework problem. Think about it today. It's not easy. That is why I'm keeping it as a homework problem. I want you all to work on it. If you understood the previous problem, you should be able to solve it. Okay. Now, the next problem, if you guys understood it. What is the smallest range covering elements from K lists? It is constant. I will share the link. It is there on CSCS. Okay. It is like min cost making median something like that. I'll share the link. Okay. I think yes, exactly. Garv shared it on chat. You can have a look and solve it. It's not easy. Take some time. It will take some time, an hour or two maybe, but it's worth solving. I don't think there is a linear solution to the first problem, Manikya, because you would need to sort the elements, right? Regardless, you would need to maintain order. And I don't think that is possible linearly. You would need to maintain a set or some data structure like that, map, multi-set. Okay. Now, what does this problem say, guys? This is actually a very beautiful idea. It's more about how you, and it's one of those problems where it's not a fixed size sliding window. Okay. This is more about 2 pointers, advanced 2 pointers. So let's have a look. There is sliding window, right? But how to implement, how to think about it, it's a very beautiful problem. So what does this problem say? smallest range covering elements from K list. We are given K lists, okay, and we need to find the smallest range that includes at least one element from each list. In this case, for these lists, okay, there are three lists. Our answer is 20 to 24 because in between 20 to 24, you can see that 24 is occurring once, 20 is occurring, and even 22 is occurring, right? So this is the smallest range such that at least one element from each list has been taken. Is the problem clear with everyone, guys? Tell me. Yes? Okay. Now, if the problem is clear, do you want time to think about it or should I share the idea? Do you guys want like, okay. So it's currently 2:26. Let's wait till 2:30 p.m. and I will share the solution at 2:30 p.m. Okay. Let's wait and let's see. Question link. Okay. I will let me share the question link. 1 second, guys.
Can you show the question?
Yes. This is the question, and let me share the link as well to everyone. And here is the link. Okay. I am using dark theme. Okay. Just, oh yeah, on lead code makes sense. Okay. Okay. So guys, what does the problem say? Okay. The problem says that we are given some lists. Okay. And what do we want to find? We want to find the smallest range A to B such that each list has at least one element in this range. Yes or no, guys? This is the problem statement. Okay. Now, you can think of various approaches to solve this. But what is our task, guys? If you look at the number line, okay, if you look at this problem like this, okay, you look at 0, 1, 2, 3, 4, 5, 6, 7, so on and so forth, 8, 9, so on and so forth up to infinity. Okay. Do you guys agree that if 3, 5 is my answer, okay, and so all indexes from 0 to n minus 1 would be there inside this range? Basically, what I'm trying to say is, if these are the elements, and for each element, I store which lists contain it. Okay. For example, 0 is contained in list 0, list 3, so on and so forth. List 3 is contained in 0 and 4. List 5, 4, the number 4 is contained in 1 and 2. List 5 is contained in, let's say, 3 and 5. Do you guys agree that the range 3 to 5 will contain all indexes from 0 to n minus 1? Yes or no, guys?
Can you repeat?
Okay. If this represents the elements, okay, let me just erase this and explain it again. Is this much clear? Like, this is just an infinite number line. Okay. Now, for each number, let me store which lists contain it. For example, if you look at this, you can see 0, 9, 12. The second list is 0, 9, 12, and 20. So on the 0th index, we'll store the index 1. Okay. And even in 9, we'll store the index 1. Similarly, if you look at 4, 10, 15, 24, 26, so at 4, I will store 0 and so on and so forth. Similarly, for 5, I will store 2 because index 2 contains it, right? And maybe some other list also contains it. List 0 contains it. So for every number, I will store which lists contain it. Is this much clear? Yes or no, guys? Tell me. Yes? Okay. Now, if this much is clear, Anish says it is not clear. What is not clear, Anish? Tell me. There are not infinite numbers. I will tell you how we can optimize this. Okay. Let's consider we are considering infinite numbers for now, but I'll show you how it does not matter. Okay. So, tell me, guys, if my answer is 3, 5, okay, let's say 1 is contained over here. Do you guys agree? I will get to all these, how to implement it and so on and so forth. Just bear with me, okay? Do you guys agree that if I take all the indices in the range 3 to 5, the elements that are there in those lists, if I take those indices, it will give me all indices in the range 0 to n minus 1? Yes or no, guys? So, isn't my task to find the smallest sliding window that contains all indices, or basically the set size is equal to n. Now tell this to me, guys. How, tell me, do you guys not know for a particular sliding window how to check? Okay, how to check if all indices are there? If all indices are there, tell me. Yes, we learned this in the last class. The map size is equal to k. Yes or no? Yes? Yes or no? Okay. Now, there were some doubts in students' minds. The first is there are infinite numbers. Though, how do we maintain this? Okay. So, first question for y'all is, guys, do we really need infinite numbers? Or we need only those numbers which are there in the lists? For example, 0, 2, 4. The second list is 5, 9, 12. And the next list is, let's say, 19, 24, and 30. Do you guys agree that we only need the number 0, 2, 4, 5, 9, 12, 19, 24, and 30? Because my range where it will be contained are going to be these numbers only. Why would I choose any number that is not a bound? I need the smallest index, right? Let's say my answer is 3 and 5. Can I not say that 3 and 5 are elements from the list? Because if you look at here, if 20 was not part of any list, I could have just taken it as 21, 24. Yes or no, guys? But 20 is part of some list and 24 is also part of some list. Yes? So, do you guys agree that the only numbers that matter are numbers from the list? Numbers from list only matter. Yes or no, guys? Tell me. 1 second, guys. Okay, I am back. So, guys, do you guys agree that the only numbers that matter are from the list? Yes. So, the only numbers that we need to consider are the numbers from the list. So, guys, some of you are telling me that I can maintain a map, which is possible. Okay. But there is a much simpler way to do this. Someone mentioned it in the chat before. I would like to take this up. Okay. If for all elements 0, 2, and let's say the second one is 3, 4, and the next one is, let's say, 1, 5. Okay. For all elements, I can just store which list it came from. Okay. 0, 0, 2, 0. This 2 came from a 0. Okay. 3 came from 1. Okay. 4 came from 1. Okay. 1 came from the second list and 5 came from the second list. Can't I just sort this? Tell me, guys. And if I sort it, what do I get? I get 0, 0. Then I get 1, 2. Then I get 2, 0. Then I get 3, 1. Then I get 4, 1. And after that, I get 5, 2. Yes or no, guys? Okay. Are these sorted? I don't know. Is it given? Yeah, you can merge them if you want. You can merge those lists if you want. Instead of sorting, you could just merge them if you want. Sorting also works. Okay. You can just apply K pointer and merge them. That is also fine. Okay. Can we do something like pointers in array? I don't get what you're trying to say. Sure. Yes, for merging you can do that. Yes, for merging you can definitely do that. Okay. Now, guys, now once we have formed this particular array, okay, what were the two things that we did? First, we deduced that the goal is to just find the smallest. I'm teaching you new things today. Keep this in mind, okay? Our goal was to find the smallest range which contains all indices, okay? After that, we saw how can we maintain these elements. Now, do you guys agree we can have a variable sliding pointer, variable sliding window to find this particular range? Yes or no, guys? Now, how do we maintain a variable sliding window? Let's have a look. Okay. The task is to find the size of the sliding window, right? It is not fixed. You can have it fixed. Okay. For fixed, what do you do? Let me share. There are two solutions. One is fixed size sliding window. And second is variable size sliding window. Okay. How do we solve using both techniques? Let me show you. Exactly. Amazing, Ayush. For fixed size sliding window, we can binary search. Okay. Binary search on the length. Okay. Basically, is the range of L2RX. We can binary search on length. And then for each length, okay, for each length, we do a sliding window approach, fixed sliding window solution. Yes or no, guys? Tell me. Is this idea clear? I can just binary search on the length, and then for each length, I can write a sliding window solution. Yes? Tell me, guys. Okay. Now, that is not really required. Why? I will tell you. Till now, we have seen what fixed size variable windows are. But there is a much easier way to solve this problem using variable size sliding windows. More about variable size sliding windows we'll learn next week. But let me give you a simple idea of how variable size sliding windows can be managed. Okay. Let's say initially my left pointer is at 0. Okay. After that, I reach some particular index. Okay. Where mp.size is equal to n. Okay. Isn't this the constraint? Yes or no, guys?
By this, it means like, all of the indices are covered, right? If m dot size is n.
Yes, yes. Okay. Someone asking what is binary search on length? What does it mean? Okay, let me just cover it briefly. We know the range. Let's say the answer is L to R, right? It means that the range of elements is R minus L plus 1. This is the number that we want to minimize, right? So we can just binary search on this length, basically the window size. Yes or no? It's not window size of the array, but window size of the range. Yes, binary search on us. Okay. This is not that optimized. This is just something, if you really want to do it using fixed size sliding window, you can do it using it. Okay. Not best solve. Okay. Now, guys, map size is equal to n. What does this mean? N is the number of lists. Okay. Number of lists. This means that all indices from 0 to n minus 1 have been taken. Yes or no, guys? Tell me. Yes? So, guys, do you agree that it might be possible that I can take this pointer ahead more, the left pointer, and it would still hold the condition? Yes or no? As Krish said, we need to shrink the sliding window size. So the only thing that I am changing is when I start shrinking my sliding window and find an index or find the last index till where it is possible, and then if this is index j, then my answer is just whatever is minimum of answer comma I minus j plus 1. This is the range of elements, not I minus j plus 1. It is ARR of I minus ARR of j plus 1. Yes or no, guys?
Can
Tell
you
me.
explain this variable side? It's not clear.
Yes, sure. Okay. So, guys, we are maintaining a map. Yes or no? Okay. Now, if we are maintaining a map, initially I am taking all elements from 0 up till a particular index I. At that index I come to know that mp dot size is equal to n, which is the number of lists. Okay. Do you agree that this window satisfies the constraint that we want? Yes or no? Yes.
MP dot size one means like the second element size is n.
No, no. This is a map in which we are maintaining the indices that have been taken in this range. Okay. When map size is equal to n, do you agree that all indices from 0, 1, 2 up till n minus 1 have been taken?
Yes.
Yes. So do
Yeah.
you agree that this is an valid window?
Yes.
Okay. Now, do you agree that it might be possible to move this pointer ahead and it still would be a valid window?
Oh, provided it still remains of size n, right?
No, 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 no. Yeah. Given that mp dot size is n. Yes.
Yes.
Yes. So what can I do? Basically, I can just move this pointer ahead by 1, basically erase this element. then I can still check, is MP dot size equal to n? If yes, it means that this is a valid window, yes or no?
Correct.
And then I can still shrink ahead and check again. And I can keep doing that till it is valid. Yes?
Yeah. Yeah.
And then I can say, I will come across a point such that I can't move it ahead. And at that point, I can say this is the smallest window for that particular index. Yes or no? For I, this is the smallest window that satisfies the constraints.
Yeah.
Yes. And then I can move my right pointer ahead by 1, basically to I plus 1.
Correct.
Yes. So first we are moving our I pointer ahead up till a point that we reach MP dot size is equal to n. After that, what we are doing is we are moving our left pointer ahead till the point that this constraint holds. Is this idea clear with everyone, guys?
Once the left pointer reaches a place where minimum is satisfied, we need to restart again, right? From, say, example, if we want to consider other answers,
What do you mean by restart?
like we found the smallest window for a particular I.
Okay,
Then if we need to compute other answers, like if there is
I plus
something,
for I plus 1.
so we'll be moving the right pointer, or like we can start left pointer from I plus 1.
No. See, the left pointer is currently at 2 and my right pointer is at I. Yes.
Yes.
And some data is being stored in map.
Yeah.
Now, do you agree when I can just move this right pointer to I plus 1 and insert this element inside my map?
Yeah.
Okay. And then I can just move my left pointer ahead till the point it is valid.
Okay, understood. Yeah.
Okay. So someone says that I think you can move to implementation, everything would be clear. Let's do that. Garv says this is as min length subarray sum is equal to k. No, this is not the same, right? Let me take an example. Okay, let me take the first example. I think a dry run over the code would definitely help. Let me delete this slide. Okay. So this is the solution. I'll show the solution and then I'll do a quick dry run. Initially, I'm having a vector of pairs where I am having the element, comma, the index. Okay. After that, for each list, I am iterating through all the elements and I am pushing back element, comma, which list it came from. Is this much clear for everyone? Okay. Now, I am sorting the array and I am maintaining a map. Okay. Now, what am I doing? Initially, my answer is from 1 to 199, basically from the lowest possible to the highest possible. Basically saying that this range is definitely going to satisfy my problem, right? Because the elements are in range 1 to 199 or 1 to 195. Yes. So I can say that 1 to 199 will definitely satisfy my answer. Yes. Okay. Now, first, what do? I insert element which is at position ARR I. Okay. Keep in mind that J is initially at 0. It is just an index which is initially at 0. Okay. Now, this is the condition that we want to see. When MP dot size is equal to N or nums dot size. Okay. Yeah. So that range will definitely be satisfied. You can take it as minus 199 as well. Instead of this, you take it as minus 199. Okay. It will definitely be satisfied. Now,
Yeah, why
Yes.
do we require to do j minus minus after the loop ends?
Yes, I'm coming to that. Okay. So guys, here, while the condition is satisfied, do you guys agree that I am erasing the existence of that element? Then if the frequency is zero, I am erasing it from map. Okay. And then I am basically iterating, or I'm putting my J pointer one step ahead. Yes or no? Now it might be after a point. Okay. Let's say I am at index 3, and at index 3 it is satisfied. But after moving ahead to index 4, it might be that it is not satisfied, right? And that is when my while loop breaks. Okay. Now, since this is where the while loop breaks, do you agree that index 3 is where we want our pointer to be? Yes. So that is why in the end, I'm doing a j minus minus, because we need to take our left pointer one step back, because where currently our left pointer is, that does not satisfy the condition. Okay. And after that, I am also putting it back inside my map. Since I had deleted it, I need to reinstate it or put it back. Let me not use fancy words. I need to put it back. Okay, someone asks, we could also have just updated the answer in the while loop to avoid this. What do you mean by that? You can feel free to unmute and ask if you have doubts, guys.
So like in while loop only the condition is correct, right? Map dot size is equals to nums dot size.
Yes.
Below that only we can update our answer if it is matching the condition, and then we can increment j plus plus, and we might not require to do j minus minus and add it again inside our map.
No. In the next condition, okay, for I, okay, it's satisfied for 3. Okay. But for I plus 1, how do you know that this is the best? We know that if I start from 3 and I take till I plus 1, it is a valid answer. But we don't know if I start from j plus 1 to I plus 1, it is a valid answer or not. And in that case, we could have missed it out, right? I get it. You can do that. But intuitively, if you think about it, isn't it just better to keep it here? We could do what you say. I get it. We can do what you say as well. Okay. So it would technically work what someone suggested right now, that in this solution is happening is that we are updating the answer here. Okay. So we could keep this inside the while loop, and then we don't need to do this again. But since like both cases work, just for simplicity, I am updating it outside. I hope it is clear for everyone, guys. Is it clear? If you have doubts, feel free to unmute, ask them. I will definitely clear it for y'all. How do we prove that it would always be able to find the smallest possible range? Okay. What is the mathematical proof of this, right? Let me share. Okay. So guys, what is the proof that our solution works? Right? So guys, the proof is that for every number in any list, okay, right? What are we doing? We are finding for every number x in the list, okay, for every number x in the list, we are finding the largest y, okay, the largest y such that, okay, such that y comma x includes all indices. Yes or no, guys? Yes. For every number x in the array, we are finding the largest y such that the range y comma x includes all indices in basically all lists. Yes or no? Now, since we are doing it for every x, isn't this kind of brute force which is bound to give us the answer? Yes. All indices 0 to n minus 1. All list indices. Yes. This is basically the mathematical proof that you require to say that your solution works. This is a very important skill to have. You can prove your solutions. It will help you a lot. So since for every number x in the list, we are finding the largest y such that y2x includes all list indices, we are definitely bound to find the smallest range. Okay. And one more basic observation is that we the range y to x. Okay, this is, I think this should be very clear. If our answer is L to R, these both are going to be numbers from the lists. Okay, this I think is very obvious, and this is the thing that I wanted to focus upon. These 2 points together, it proves the solution, right? L to R will always be numbers from the list. And second thing is that for every number x in the lists, in any list, we are finding the largest y. What if num
For
dot
the
size?
for the
Yes,
answer variable, we are maintaining the indexes that we are keeping, right? The leftmost index and the rightmost. That constitutes the map size, right?
the leftmost and rightmost index.
In the answer variable, we are keeping that there, right? The
In the answer variable, yes, we are keeping the leftmost element and the rightmost element. Yes.
But how are we maintaining the minimum? Like,
Using this, like we will know the minimum through the length, right? If I say that L2R satisfies my constraint, what is the number of elements in that range? It is R minus L plus 1. So if my current R minus L plus 1 is greater than ARR I dot first minus ARR J dot first plus 1, then I can just update my answer.
yep.
Okay. Exactly. We are removing the elements from back one by one. And this is what we call as variable window size. Okay.
No worries. I want to ask one
Yes.
thing: how we are maintaining the sliding window that will give the minimum length?
Okay. So this is something that we are doing greedily. I think this is going to be taken up next week. I was not aware of that, but yes. So how are we finding minimum length? Do you agree that the numbers are sorted? Okay. Yes or no?
Yes, yes.
Let's say from index 0 to index I came to know that this satisfies the constraints. Okay. This is a valid window. Okay. Now, let's say this number is some x. Okay. Our task is to find the furthest index such that it still satisfies, right?
Yeah.
So my left pointer was initially at 0. Do you agree that if my most possible answer is still here, okay, this still satisfies the constraints. Do you agree that moving this one step ahead would still satisfy the constraints
Yes.
up till here? So that is what I'm doing. It's a greedy idea, right? I move this one pointer ahead and then I check, is it still valid? If it is, then I move it one pointer ahead. I do it till the point it is not valid. And after that, I just move it back to where it was. I move it.
Yeah, one thing more I want to
Yes.
one thing I want to ask is that it can be like that we are discontinuous. After X, we got another sliding window which is giving the minimum than that.
What do you mean by that?
Miss, there are two sliding windows which are giving that all the lists are covered in that. Then
Yes.
what we can do for that?
Which two sliding windows?
Miss,
Good.
there are two sliding windows which includes all the lists, but we want to find the minimum one. Then what we can do
Yes.
for that?
Okay. So for index I, we found J. Okay. What is the length of it? It is I minus J plus 1. Yes or no?
Yes.
Yes. Okay. Let's say for some other particular sliding window, which is X to Y, we found the length. What is the length? It is X minus Y plus 1. Yes or no?
Yes.
This is not I and J. Sorry. This is ARR I and ARR J, right? ARR I minus ARR J plus 1, and this will be ARR X minus ARR Y plus 1. These are the two sliding windows that satisfy the constraints. Okay.
Yeah.
Now, which one would you take? The one which gives smaller numbers, right?
Yeah.
So if this range, let's say this is 3 to 5, and let's say this is 6 to 10, which one would you take? This consists of 3 numbers. This consists of 5 numbers. Which one would you take? This one, right?
Yeah.
So you would take the one which has minimum ARR I minus ARR J plus 1. Yes or no?
Yes.
Yes. Okay. So that is exactly what we are doing here. We are checking if ARR I minus ARR J plus 1 is smaller than my current answer. And if it is indeed smaller than my current answer, I am just updating my answer to that.
Yeah. Yes. Okay. Got it.
Okay.
Yeah.
Okay.
Thank you.
So, guys, this variable sliding window is something that we would be covering next class. Okay. I realized that this was supposed to be due for next week. Okay. So if you don't understand variable sliding window in detail, it is fine. Right? Just why not MP AII still understood the concept, right? My idea was to make you guys understand the concept. We would be covering this in detail next week. Okay. So if you are like, I don't understand this, it's okay. It's definitely okay. Right. The next problem that I was supposed to cover, it requires a lot of understanding of variable sliding window. So maybe I would have to take it up next week. Right. Please give us some easy, medium. Definitely, I'll share those problems as well. And someone asks me this question, right? Why did we take dot second plus plus and not dot first plus plus? A very simple reason for that is, let me add a page over here. Okay. We want to maintain in map. What do we want to maintain? We want to maintain the indices, right? Yes or no? Tell me, guys. In the map, we want to maintain the indices because mp dot size is equal to n. What does this mean? It means that there are n indices, okay, which is 0, 1, 2, so on and so forth. 0 to n minus 1. And what are we storing in the array? We are storing the element, comma, the list index. So that is why I am doing dot second plus plus. Do you agree? We are storing the map to store the index, and we are using this element to find the range. Is this clear, guys? Okay,
One
I get
another
it.
thing.
Yes,
For
tell me.
example, we maintain the number line and we do plus, we insert like a particular element occurs at which maps. So the answer would be when for a particular element it is n, and we can say k plus 1 as well, right? Like if the ith element contains map dot size equals n, and we can say I
Okay.
and I plus 1, right? The first solution is that.
What do you mean by that?
Like on number line, we can maintain like map for each of the elements.
Yes,
And
for implementation, right? Yes, you can do that as well. Yes, you can store a map of int, comma, vector. Okay. And in this vector, you can store the indices, which is there for each element. Yes, you can do that as well.
so in that case, our key and say key plus 1, we can take as the answer, right?
In that case, why I didn't do that is because you can't maintain indices there. These indices would need to be iterators. Do you get it? Because here I am starting from 0. Okay. Yes or no? And from 0 to ARRI, I can say that it satisfies. But in a map, if I want to go ahead, it has to be the next key. Yes or no?
No, I'm saying, for example, we maintain all the unique numbers on a number line. And for each, we maintain this map int, comma, vector int.